So in this video, we're going to graphically determine a limit in the case where the two one-sided limits don't exist, and because the one-sided limits don't exist, the limit itself will not exist. So in this case, we have a function f of x equals x squared minus 5 over x minus 2. We want to right away notice that x cannot equal 2 because plugging in a 2 would cause a division by 0, which is undefined. So we want to notice that f of 2 is undefined. And in this case, x squared minus 5 doesn't factor in a way that will get the x minus 2 to cancel out of the denominator for us. So it turns out that x equal to 2 right here is a vertical asymptote for the rational function. So we get a vertical asymptote at 2. So just like in the previous example, step 1 is draw a graph of the function, which I did. So here's the graph of the function. And then we want to establish two open intervals centered at 2. In this case, the domain of the function is any real number except 2. 2 is the only number we can't plug into the function because it causes a division by 2. So using the domain of the function, which is x is an element of the open interval from negative infinity to 2, union from the open interval from 2 to infinity, this gives us two open intervals that are convenient to use in this particular case. So just like we've done before, we're going to let x go to 2 from the left side interval. This left-sided interval, let x approach 2. So take the limit as x approaches 2 from the left-sided interval or from the negative side. So we're going to let x approach an input of 2, and what we want to notice is that the graph, as x approaches 2, the graph is actually going to infinity. In other words, the outputs are going towards infinity as the inputs approach x equal to 2, the location of the vertical asymptote. So the limit as x goes to 2 from the negative side of f of x is infinity because the graphical outputs are becoming infinitely large. And now we're going to let x go to 2 from this right side open interval. So we're going to take the limit as the inputs get closer to an input of 2 from the right interval. So that's from the positive side of the function f of x. And what we want to notice is that as the inputs approach x equal to 2, the function is going to negative infinity along its vertical asymptote. So the outputs are becoming infinitely large but negative as x approaches 2 from the positive side. So in this case, we have two issues going on. One, the left-hand limit, the left-sided limit, and the right-sided limit are different. The left-sided limit is infinity. The right-sided limit is negative infinity. So the one issue is they don't match. But we have even more of an issue in that the limit doesn't exist because infinity and negative infinity are not numbers. They are not real numbers. So for the limit to exist, the two one-sided limits both have to be equal to real numbers. So the limits do not exist. In fact, if I'm after the limit as x goes to 2 of f of x, I could have stopped here. The moment I see that the left-sided limit isn't a real number, I'm done. I know that the limit does not exist. So here I'm going to draw a conclusion. Because the one-sided limits do not exist, the limit as x goes to 2 of the function does not exist. We could also say that it doesn't exist because the two one-sided limits are not equal.